Do these words at least sound familiar? Have you heard these words before? Okay. So ratio is a quotient of two numbers that represent quantities of the same kind. So if I wanted to compare the number of students in my class to the number of students in Mrs. Elsie's class, that would be a ratio, okay, because it's students being compared to students, okay? What's quotient mean? Anyone know what quotient means?
Quotient.
It's what kind of problem?
Division.
Division, yeah. Quotient means divide.
Means divide.
Okay, so ratios are really just a fancy division problem. What's that? Mrs. DeVries. Echoes, and I hate that I'm glaring myself in the face. A ratio compares two things that are the same types of things. If you were comparing things that were different, like like miles and time, distance and time, which is speed, right? That's called a rate. So if you're comparing things with two different units, that's a rate. If you're comparing things with the same unit, that's a ratio. And as you said, ratio is a fancy for fraction. Okay, because a fraction is just a division problem, right? Okay. Oops. Well, you could turn a fraction into a percentage, sure. A percentage is a ratio.
A percentage is a fraction.
Mm-hmm. Yeah, a percentage is a fraction. 65% is 65 out of 100. Blow your mind just now?
Yeah.
Okay, the size change distance theorem. I don't think I actually called it a theorem because I don't care that you know the names of theorems. But the size change distance theorem is the last thing we talked about yesterday, and that was where we said that anytime you have a size change, the ratio of the lengths is always going to be multiplied by that magnitude k. So if you found the length in an old one, like the original figure, I guess I should say, if you found a length in the original figure multiplied by the magnitude, that would give you the length in the new figure, okay? Like this. This is the correct way to write it out, and we sort of wrote that in our homework assignment. Remember when I had you write, h prime w prime equals 2 times hw? That's what that was, okay? That's the size change distance theorem, yeah. We wrote it in words in our notes yesterday, but this is sort of the shorthand for it. I don't like how I wrote that.
The star is multiplication sign?
Yeah, star is multiplication sign. Mm-hmm.
It kind of looked like a hand or arrow. It's like little fingers.
Oops, it's my pen.
Is that a snowflake?
It's multiplication. Just so you know,
It's a hash.
when you're typing, you guys probably haven't seen this yet. When you're typing, if you don't have access to like the regular multiplication symbol, like a dot or something like that, the star is what you use as multiplication. And probably you guys will never even have to use that because you have fancy things that'll let you type with the multiplication symbol. But when I went to college, this is what it was.
Back in my day.
Back in my day, that's right. Okay, let's take this. Let's take this here and rearrange it, okay? If I wanted to solve that for k, if I wanted to get k by itself, how could I get rid of the ab over here? How could I get rid of that? Divide it, right? If I did that, it would be something like this. Okay? So really what this is saying is if you take a length in the new figure, divide it by a length in the old figure, that'll get you your magnitude. And we just did that. Remember that homework example we just did from 12.3, where we had that one length was 18 and the other length was 12, and we ended up doing 18 divided by 12 to get our magnitude? This right here is exactly what we did. We just hadn't written it down that way. And look at that. This is called a ratio. Okay? And by the way, another word you're going to hear me throw around for K, we've called it the magnitude so far, all right? But it's also called a ratio of similitude. Throw that one out there and sound fancy.
That's what I was thinking.
Okay, that's what you were thinking? Exactly? All right. That K value can also be called a ratio of similitude.
You just say,
Okay. And then this, did I leave this in there or do you have to write it? Okay. Since the magnitude K stays constant under a size change, so that means that any piece of the figure that you look at, that K value will be the same. The ratios of the corresponding lengths are always equal to each other. Okay? So if I have two triangles where one is a size change of the other, if I divide a big side by a small side, and then pick another pair of sides and divide the big side by the small side, they should both come out to be that same K value. Okay? Let me draw that so you can see what so if I have this and this, okay, where this is, let's see, 12, 10, 11, let's say, and this is 6, 5, 5.5. These two are similar to each other, these two triangles, meaning that they have a constant, that they're a size change of one another. So I did a size change to the red one, turned it into the blue one. Okay? If that's true, I should be able to take this number divided by this number and get the same thing as if I did this number divided by this number. Right? Or this number divided by this number. So any pair of sides I pick to divide is always going to come out to that ratio, which in this one, what would that K value be? 2. They would all come out to be 2. Okay, so that's handy for this, proportions. A proportion is a statement that two ratios are equal to each other. Didn't we just talk about ratios being equal to each other? I think you do need to write that in. I think there's a little star there for you to write it next to. Okay? A proportion is a statement that two ratios or fractions are equal to each other. Okay? If you can't fit it in, that's okay. You've got a picture of one right in front of you there.
Why is yours color and ours isn't? Why is yours color and ours isn't?
Because I can't afford to print all your stuff on color. So a proportion is like something over something that's equal to something over something. Okay? So it's two fractions that are equal to each other. When you have that, when you have two fractions equal to each other, they form what's called, well, they form a proportion, but within a proportion you have what's called the means and the extremes. All right? I would not stress a ton about which is which. I'm going to show you why the means and extremes are important in a minute. But the extremes are basically the first one and the last one. If you were to sort of number these, like 1, 2, 3, 4, the extremes are the first and the last, and then the means are the two in the middle. Okay? And here's why the means and extremes are important. The extremes property says in a proportion, the product of the means is equal to the product of the extremes. What's product mean? Multiplication, yep. Which actually I'm going to have something pop up right where I wrote that. But so what that means is if you multiply the A number and the D number, it's going to be equal to what you would get if you multiplied the B number and the C number. Okay. Does this sound familiar?
Yeah.
Good. So here's a shortcut way to write that. Let me move that so you can see it. So A times D is equal to B times C, using that example up at the top. If you multiply the A and the D, that's going to be equal to the B times the C. Cross multiplication. Yeah, that's exactly what this is. Yep, cross multiplying. Now, what I am going to tell you that's going to make me less popular is you may have learned a shortcut for doing these before, okay? you are going to have to write them out like equations now. Okay, because I know what types of problems you're going to end up seeing, you're going to have to be able to write them as an equation. I'll show you what I mean by that in just a minute. But if you think you know how to do this already and it involves just a quick like button pushing, you are going to have to do some writing for these. Not a lot, but some. Okay, so if I was to solve this proportion, okay, basically I'm trying to figure out what x is. You are going to get some of these that you can figure out in your head, okay? But what I would do, Bryce, question? It is, but we have to talk about how to get the answer. Because when you get to things even like this, that quick little shortcut's not going to work for you. Okay? So I'm going to multiply my 2 and my x. So I'm going to say 2 times x is equal to, and then I'm going to multiply the 3 and the 5, which is 15. Okay, you must have this equation part written down, even if it's really easy. Okay, I want you to write this part out. Now from here to solve this shouldn't be a problem, right? Divide by 2, and x equals 7.5. Now over here for this one, when I go to do 7 times 2x minus 1, I need to multiply 7 by that whole thing. So what do you think I need to use to show that I'm multiplying by a whole thing? Okay, distributive property, which means I'm going to write it with parentheses. So I'm going to write 7 and then parentheses 2x minus 1 equals, and then I'm going to multiply 10 times 10.5. Is that going to be 105? You check that for me.
Yeah.
105. So again, I must see this setup here. Let's distribute the 7. So this is going to be 14x minus 7 equals 105. What now?
All of the 7.
Add the 7. So 14x equals 112.
How do you divide it by 4?
Divide by 14.
14.
Is it 8? Check it for me. 112 divided by 14.
8.
It is 8? Okay. Okay. Now you're going to see why we're going to be using these. Okay. So when you do a size change, the side lengths stay proportional. And that's because of what we were just talking about, that any pair that you set up in a fraction is always going to be equal to that k value. So that means they're all equal to each other. So it says triangle ABC is the image of triangle DEF under a size change. So if they are equal under a size change, that means their ratio stays the same and we can set up a proportion. So where do you see, if you're looking at these numbers to be compared with these numbers, which pair of numbers goes together? No variables yet. Just where do you see a pair of numbers that goes together? Travis? 10 and 4. Yep. So I'm going to set up my first proportion as 10 over 4.
Can you do that one if you had it?
Well, I want you to at least write down the setup in your notes, okay? But you're probably not going to be getting a whole lot that you can just do in your head, so I would make sure to write them down, okay? Now, the way Travis said this to me, he said 10 over 4. So when I go to pair up my next two, I want to make sure I start with this triangle because I started with the 10 on top. It would have been okay to put the 4 on top instead, all right? But however you start the first one, you've got to start the second one. So what goes with the x over here? The 20. So I'm going to set this one up as 20 over x. Okay. Let's cross multiply. So 10x equals 80. What does x equal?
8.
X equals 8. Okay. Just curious, those of you who said you wanted to do it in your head, what process would you have used? Like, how did you reason it out in your head? Isaiah?
I have a question.
Sure.
Why did we not use the line?
Oh, we're going to.
Okay.
Okay? When you're doing a proportion, you want to make sure you only have one variable in there because you can't solve for more than one variable. So that's why I told us to start with this pair of numbers that we know both the numbers for, and then you just put one variable in. Then we're going to do it again with the other variable. Okay? Travis, talk me through your process.
Well, I did 10 divided by 4.
Okay.
And I got 2.5.
Okay.
Then I did,
So what you just found was K.
yeah.
You found the ratio. Yep.
So I did 20 divided by 2.5.
Okay.
I got 8.
Yep.
And then I did the same thing. And then I did,
Probably would have done 5 times
Yeah,
2.5 to get the other one, right? Yeah. And that's a totally valid way to do it. I do want you to see it this way, but I'm okay with you reasoning it out like that. Okay? Now, on your paper, Travis, what I would want you to do is write down what you did. Okay? So even if you just wrote down, 10 divided by 4 is 2.5 and, so on. That's fine. So now I'm going to set up one to find the y value. Okay? Now, the y value goes with the 5. What I would recommend to you, technically at this point, we could use the 10 and the 4 again, or we could use the 20 and the 8. I recommend you try to go back to the numbers that are given to you in the problem, because what happens if you made a mistake on that 8? Would that mess you up for y?
yeah.
Yeah. So try to use the original numbers whenever possible. So I would say, move this over a little bit. Now for my new one, I would also start with 10 over 4. But this time I'm going to say y over 5. Okay. And I'm making sure the 5 is across from the 4 because these two are in the same triangle together. So now I would cross multiply. I get 50 equals 4y. Divide by 4, divide by 4. 12.5, thank you. Okay. See what I mean? Super easy stuff today? Yes? Good? Not a ton. 14 problems, I think. But they should be easy. No proofs. Okay. A dollhouse is built to be an exact replica of an actual Victorian mansion. In the mansion, the actual mansion, an oval-shaped table is 6.5 feet long and 4 feet wide. In the dollhouse, the table is 3.25 inches long. How wide is the table in the dollhouse? So this would be something that's an image under a size change, right? Because it's taking a large table and shrinking it, but you want it to stay proportional. So in the original mansion, my two lengths are 6.5 and 4. So I would say I know 6.5, which is the length. Actually, let me do this over here. 6.5 is my length over 4, which is my width. And this is in the original house. I'm going to set that equal to the dollhouse. And it gives me that in the dollhouse, the table is 3.25 inches long. So first of all, how do you write 3.25? 3.25. Does that go on the top or the bottom? The top, because it's the length. Brianna?
But you want them to be equal feet and inches.
Oh, with a ratio, you don't have to. As long as the two that you're comparing, like these are both in feet, these will both be in inches. Okay? But yeah, good question. Because a lot of the times when you're doing these scale things, you're going from something very big, like feet or yards, to something very small. So, good question. 3.25 up here. And then this is like our x. This is what we're solving for. So let's multiply and multiply. 4 times 3.25, I think is going to be 13. Is that right? So 13 equals 6.5x.
Yeah.
Answer's 2 for whoever just said that.
That's right.
So that would be 2 inches is the width of your dollhouse. Or not the width of your dollhouse, the width of the table in the dollhouse. Okay? So anytime you have two figures that have undergone a size change, where a smaller thing has been turned into a bigger thing or vice versa, okay? You can apply this proportion reasoning. How do you feel?
Pretty good.
Easy? Good?